My name's Chris Exton. I'm a lecturer in the University of Limerick in the Department of Computer Science and Information Systems. And what I'd like to talk to you about today is a broader view of computer science education, or IT education if you want. I'm not talking about using software. I'm not talking about teaching somebody how to use Word. I'm not talking about how to use Excel or how to use any particular software product. I'm talking about an understanding of how it works. So let me pose a question to you. I know the fact that you're looking and listening at this means that you're using some sort of device. You're using some sort of computer, maybe a smartphone, maybe you've got headphones on, maybe you're listening through speakers. Can you give me a model of how this works? Can you explain to me, even in a simple way, how this data is getting on your screen, how my voice is getting to your ears? Can you give me a simple explanation? Most people will happily wear the badge that says, computers, I don't really understand that. We need to get over this. There's lots of talk about the information society, there's lots of talk about computing in Ireland. We need to step beyond IT as users and move into IT as a concept and IT as a process of thinking. So let's, for example, consider your screen, or in fact any screen that you look at. How does it arrive? How does it get there? How do we see color on a screen? It's a really interesting question and a fundamental one. Nearly everybody spends now probably at least an hour of their day staring into some sort of screen. Maybe their phone, maybe their television, maybe a computer screen. And yet it's quite simple models about how they work. Most people don't have them. So I want to think about color and how it happens to appear on your screen, and in fact how color is represented as a series of numbers. Firstly, we've got to understand that the output device, or the screen you're looking at, is built for the human eye. And the back of our eye is our retina, and that's composed of rods and cones. We have three types of rods. Each one is sensitive to a different wavelength of light. One is sensitive to red, one is sensitive to green, and one is sensitive to blue. When I say nearly all of us have those, some of us are perhaps colorblind and may be missing one of those. So each pixel on your screen has a dot for red, green, and blue, which corresponds to the cones in the back of your eye. Simply, there is a number associated with each one of those pixels. So your screen is made up of maybe 1,000, 2,000, 3,000, maybe 1,000,000 pixels, depending how big it is. Each pixel is split into red, green, and blue, and for each of those is a corresponding value, usually between 0 and 255. Now, it's difficult to think that that whole picture is made up of those numbers, but that is exactly how this picture is put on your screen. It's saved as a series of numbers relating to the red, green, and blue cones that are in the back of your eye. Another aspect of computing, which we're familiar with, especially any games players out there, but in fact anybody that looks at television has seen the same, is the human concept of motion and how we perceive motion and where motion comes from. To computers, motion is really quite simple. Motion is just a series of still pictures. I've already explained how we can put a picture on the screen as a series of pixels. Now, if we put a set of pictures on the screen, maybe at a rate of 50 a second, and each picture is slightly different, we humans see it as motion. That's all motion is. Those simple models are important. If you think about screens and you think about motion or you think about pictures, it's all around us. It is the world around us. It is where we live. And yet, most people don't even have a basic understanding of how it works. So there's two main points, I suppose, I want to get across. It's now essential to demystify technology. It's now essential to bring this to the masses. There's probably still a debate of how this is going to happen. But one of the things we must be careful of is separating computer science and about how things work, about teaching how to use things. So I think there's probably at least a large movement already about teaching ICT, about how to teach students how to use Word and how to teach students how to use word processors. But we've got to move beyond that to models where we teach people how to think algorithmically, computational thought. And computer science is an excellent vehicle for this. it's different to lots of other means of learning subjects. The emphasis isn't on the retention of knowledge, it's not on remembering facts. And in fact, in the broader computing domain, it's not really necessarily to remember a lot of facts. And you get used to using tools that you can discover the facts very quickly. So the emphasis becomes on how to process the data, or concepts like abstraction, or genericness, or patterns in the data. These are the things, this is the type of thinking, the type of thought which is synonymous with computer science, and I think is a thought process or a type of thinking which it's important that we teach the next generation if we want them to function in a knowledge-based economy. It's not important to remember large bodies of facts. It's important to understand how to process them, categorize them, how to problem solve, how to sift through information. These are all aspects of computer science, so it provides a perfect vehicle for this type of thinking. I've enjoyed teaching computer science for the last 30 years. It's been fascinating to watch how it has infiltrated nearly every aspect of society. And I don't think it's going to stop. In fact, I think it's going to accelerate. It's been interesting to see how users have adopted it for all aspects of life, from entertainment to communication. And nearly every workplace has a computer of some description. In fact, none of us are probably more than a few meters from a computer. Every time you jump in a car, there's at least 5 or 6 of them under the bonnet. The time has come now, there's a tipping point. The time has come to move computer science out of the universities, into the broader community, into our secondary education system. We need to provide this if we want people to understand the world around them. Without this understanding, more and more of the world and how it functions will become a mystery. I don't want to see this happen. If you want to find out more about what I'm talking about, or in fact, if anybody wants to discuss any initiatives in this area, I'd be more than pleased to talk to you. I think there's lots of room and there's lots of effort to be put into this area, and I would love to be involved. So please contact me, either about specifics or about anything in general. Thank you.